Morning, everybody. Today we are going to talk about functions. So, first of all, what's a relation? A relation is a correspondence between two sets. So, if a relation exists between two elements in these sets, then we say x corresponds to y, or that y depends on x. And we write x implies y. This little arrow like this means implies. Okay? So, in this relation, we say that x is the input and y is the output of the relation. The relation itself is called a map or a mapping. So basically what this means is you've got a set of numbers here and a set of numbers here, and you have a map that takes things from one to the other. Okay? So these are your input, these are your output, and this is your map right here. Map tells you where to go. So here we have an example where y equals 2x plus 1. So it takes 0. 2 times 0 is 0, plus 1 is 1. It takes 3. 2 times 3 is 6, plus 1 is 7. It takes negative 2. That'd be 2 times negative 2 is negative 4, plus 1 is negative 3. And 1/2, 2 times 1/2 is 1, plus 1 is 2. So this is my map right here, my mapping. This is my input over here. This is my output over here. This is my independent variable. These are my dependent variables. Okay. So a function from x into y is a relation where every x has exactly one y. The set x is called the domain, and the set y is called the range. Okay, so if we look back here, this would be my domain. This would be my range over here. Okay, so remember, a function is a relation where every x has exactly one y. Now, the easiest way to think about that, I think, is to think about the vertical line test. So if I have a relation that looks like this, okay, and I can draw a vertical line like so, and I can move that vertical line anywhere I want, and it always only crosses that red curve in one location, then that's a function. Okay? So that means that every x down here would have exactly one y. Now what does it mean if it didn't have, if it wasn't a function? Might look something like this. Let's say I had a curve that looked like this. Okay, and then I drew my vertical line right here. Now I've got not one, but I've got two x's or two y's for each x. Okay, this is not a function. Okay, so a function would be x equals 5x minus 3. Virtually any line is a function, and if it's not vertical line. Okay, all lines that are not vertical lines are functions. Okay, vertical lines are not functions because it wouldn't pass its own. This is called the vertical line test, by the way. It would not pass that vertical line test. Things that are not functions. Okay, square roots. This would be a square root function right here. Okay, not a function. Now, you could force it to be a function if you cut it in half and you go, I'm only going to consider the positive parts, or I'm only going to consider the negative parts. Then you can make it a function, but in general, it's not a function. Okay, now down here, we have some sets of numbers. So, 1 goes to 4, 2 goes to 5, 3 goes to 6, 4 goes to 7. This is a function. Each x has exactly one y. But over here, 1 goes to 4, 1 goes to 6. This x has two y's, so that's not a function. The x variable is called the independent variable. The y variable is called the dependent variable, since it is dependent upon whatever the value of x is. So in like this equation, I can take any number I want, plug it in for x. Okay, it's independent. But once I choose an x, there is only one y that's coming out of that thing. So the y is dependent upon what the x is. Okay, characteristics of a function from set A to set B. Each element of A must be matched with an element of B. So you can't just have, an A that doesn't go anywhere. Some elements of B may not be matched with an element of A. That's okay. Two or more elements of A may be matched with the same element of B. So what would that look like? That would look like this. Like an x squared. So if I take 1 squared, I get 1. But if I take negative 1 and I square it, I also get 1. That's okay, that's a function. It passes the vertical line test. Okay? An element of A in the domain cannot be matched to different elements of B. So that would be this situation here. I can't have something like this. That's not going to work, because here I have an x let's say I just put in 0 right here. I have 3 different answers that could come out, so that's not a function. Okay, determine whether each equation represents x as a function of y. Or I'm sorry, y as a function of x. So I always like to solve for y. Okay, what is this? This is a parabola. It's an upside-down parabola. Okay. All parabolas are functions, so this is a function. Okay. What about this one? So solve for y here. I get x plus 1, and then this becomes the square root of x plus 1. Square roots are not functions. Okay, not a function. If I were to look at what this graph looked like, it would look just like this. Here's, negative 1, and the equation would look like that. Okay, this mentions the vertical line test. A relation is a function if and only if there are no vertical lines that pass through the graph more than one time. Okay, function notation. So when you see f of x equals, that's function notation, and it's pretty much exactly the same thing as this. Those are the same equation. This is just function notation, this isn't. Okay, so this lets me do things like this, right? F of 3. What does f of 3 mean? It means I take 3 and I plug it in here everywhere I see an x. So this would be 2 times 3 squared minus 3 times 3. So this would be 9 times 2 is 18 minus 9, which would be 9. So f of 3 is 9. Find f of negative x. Okay, this is a little tricky for some people. People get kind of freaked out about this. All I'm going to do is put negative x in anywhere I see an x. So this is going to be 2 times negative x squared minus 3 times negative x. Okay, so now you got to be careful here, because this is negative x times negative x, so this is 2x squared. This is a negative times a negative, which is a positive. Okay, so f of x and f of negative x are not the same thing. Here's another one that kind of gives people fits. F of x plus 3. So I'm going to take x plus 3 and plug it in everywhere that there's an x. And then I'm going to simplify it. So this is 2 times, if I FOIL this, I'm going to get x squared plus 6x plus 9. I'm going to distribute my negative 3, so this is minus 3x minus 9. Then I'm going to distribute my 2, so this is 2x squared plus 12x plus 18 minus 3x minus 9. And then I'm going to go ahead and combine my like terms, so I get 2x squared plus 9x plus 9. Okay, negative f of x. Notice this is not the same thing as this. Here are the negatives on the inside, here are the negatives on the outside. So what that means is just take your equation, 2x squared minus 3x, and make the entire thing negative. So this would be negative 2x squared plus 3x. Okay, what about f of x plus f of 3? Okay, so not hard. F of x is just 2x squared minus 3x. And then I'm going to add to that f of 3. Well, I already figured out what f of 3 was up here. F of 3 is 9. So this is just plus 9. And so this is going to be 2x squared minus 3x plus 9. Now, if I hadn't already done this, I would have to put I'd have to put 3 in here, figure out what this was, and then add it. Okay, what about this bad boy right here? We're going to come across this in calculus a bit. F of x plus h minus f of x divided by h. Okay, so don't freak out. It's not that difficult. I'm going to take x plus h, and I'm going to substitute it into this equation. So this is going to be 2 times x plus h squared minus 3 times x plus h all over h. Whoops, I forgot something. I forgot in the second half of the equation. So it's going to be all of this minus f of x. Now this needs to be in parentheses because you're subtracting the whole thing. 2x squared minus 3x, all of that over h. There we go. Okay, so a little bit of algebra here. So x plus h squared, if I FOIL that, this becomes 2 times x squared plus 2xh plus h squared. Distribute your negative 3, so that would be negative 3x minus 3h. Distribute my negative sign, that's minus 2x squared plus 3x. All of that over h. Go back and distribute your 2. So that's 2x squared plus 4xh plus 2h squared. I can kind of do this. Those cancel. Okay. So then I'm left with minus 3h minus 2x squared. All that over h. Just take your time and show the steps is the easiest way to do this. Okay, so now I've got 2x squared and a minus 2x squared. That cancels out. And so then I'm left with everything up here has an h in it, and I got an h on the bottom, so I can cancel out the h here, the h here, the h here, and one of those. So what's left? I've got 4x plus 2h minus 3. That's all that's left. That's my answer. Okay, moving right along. Piecewise functions. So piecewise functions are functions that have 2 or more parts to them. So this is x plus 1 when x is less than 3. which is just a line. This is negative 2x plus 4 when x is greater than or equal to 3. So that's also a line, but it's a different line than this one. So this thing is going to change right here at 3. Okay? So what I can do is I can graph both these lines if I want, which is easy to do, and then just eliminate the parts that don't apply. So x plus 1 is a line that has a y-intercept of 1 and a slope of 1. So it's going to go up 1 over 1, up 1 over 1, up 1 over 1, down 1 to the left 1, and so on. Okay? Now, I only want this when x is less than 3. So I'm not going to go beyond here. Okay? In fact, since it's less than, I have an open circle right here. And then this line goes like this through my graph. Okay, then this becomes negative 2x plus 4. Okay, so negative 2x plus 4, but it's only when x is greater than or equal to 3. So I'm going to go ahead and start here at 4. And then I'm going to go down 2 to the right 1. So it would go here, and then it would go down 2 to the right 1 here, down 2 to the right 1 here, down 2 to the right 1, down 2 to the right 1, and so on off the page. Okay, now I only want that from 3 on, so that's going to be equal to, so there's a closed dot here, there's that, and then I just go back and I don't want those points. So there's my graph. It's this line when x is less than 3, it's that line when x is greater than or equal to 3. Okay, find the domain and range of these functions. So, x squared plus 5x. Domain, super easy. Okay, so the domain, which we write like this, is the set of all real numbers. You can write out all real numbers if you want, but you can just write x. It's all the real numbers. Okay, I can take any number I want and square it. I can take any number that I want and multiply it by 5. Positive numbers, negative numbers, 0, whatever I want, fractions. So the domain on this is easy. Now, this is an x squared, it's a second degree polynomial, so this thing is a parabola, okay? So it's going to look something like this, okay? Which means it's going to have a bottom, so the range is not going to be all real numbers. So I just have to figure out where the range is, or what the range is. Okay, so the range, now this is going to be all the y's, all right, but there's going to be restrictions on the y's. So I could graph this thing, or I could factor this. It'd be x and x plus 5, which means that the zeros would be at 0 and negative 5. So if I were to graph it, I would have a 0 here, 2, 3, 4, 5. I would have another 0 here. Now, parabolas are symmetric to their axis of symmetry. Their axis of symmetry is going to be right in the middle here at 2.5, or negative 2.5. So this thing's going to look something like this. And at 2.5, it's going to be the bottom of this. So I'm just going to plug in 2.5 here, or negative 2.5 here, and figure out what that is. Okay, so f of negative 2.5 is going to be negative 2.5 squared plus 5 times negative 2.5. Well, that's going to be positive 6.25 minus 5 times negative 2.5, that's what, negative 12.5. Yeah. Which is negative 6.25. Okay, so this is the bottom right here. It's not going to go below that. Okay, so my range is going to be all the y's where y is greater than or equal to negative 6.25. Okay, so here's my answer right here, my domain and my range. Okay, next up, 3x divided by x squared minus 4. Okay, probably the easiest way to do this would be to graph it. You could graph that thing on your graphing calculator really easily. So 3x divided by x squared minus 4. And make sure that you have a nice window that you can look at. And then hit graph. Okay, so what does this graph look like? This is an interesting graph. And you'll see more of this later, and you'll be able to analyze this thing and know what it looks like without ever having to graph it. So, so this has, okay, if I look at the bottom of this, remember the denominator can never be 0, okay? So what makes this 0? 2 and negative 2. So the range is all the y's where y is not equal to plus or minus 2. Okay, denominators can never be 0. Okay, if I graph this thing, it looks like this. So if I just look at just this part right here, the range is all real numbers. Or the domain's all, I'm sorry. I got this backwards. Sorry, I went brain dead for a second. So this is the domain. The domain's all the x's where x is not equal to plus or minus 2. The range, there we go, that's better. The range, just this part is all real numbers. I've got all the positive numbers over here, I got all the negative numbers down here. The only thing I'm missing is 0, but there's a 0 right there. So the range is all the y's. Okay, so there's my domain and range. Okay, what about this one? H of t is the square root of 4 minus 3t. Okay, so square roots. Square roots look like this. And they look something like this in general. Okay, so we got to figure out where is this thing equal to 0, because this thing can never be negative, okay? So we're going to take 4 minus 3t, set that equal to 0. So if I add 3t to both sides, I get 3t equals 4, and then I divide by 3, it's 4/3. Okay, so 4/3 is where this thing is 0. Now, if a number is bigger than 4/3, that means this is more than 4, and that means that I had to be square rooting a negative number. Okay, so my domain on this is going to be all the x's where x is less than or equal to 4/3. Okay, so this actually is not going to look like this. It's actually going to look like this. Sorry about that. It's always going to be getting bigger like that. So the range is going to be all the y's where y is greater than or equal to 0. This will get as big as you want. A lot of people think it levels off. It doesn't level off. It gets as big as you want. It just takes some time. So here's my domain and my range here. Okay, the path of a baseball. A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees. The path of the baseball is given by f of x equals negative 0.0032x squared plus x plus 3, where f of x is the height of the baseball in feet and x is the horizontal distance from home plate in feet. Will the baseball clear a 10-foot fence located 300 feet from home plate? So, okay, this is an upside-down parabola. Okay, here's my equation. It's an upside-down parabola. It looks something like this. Okay, and the question is, if the fence is 300 feet away from home plate, and this is 10 feet high, will the ball clear the fence? Okay, so remember, f of x is the height of the ball, so all I got to do is put 300 in here. I got to find f of 300. So this would equal negative 0.0032 times 300 squared plus 300 plus 3. So at this point, I'm going to get out my handy-dandy TI-84 plus C Silver Edition graphing calculator. This looks kind of ugly, so we'll clean this up a little bit. And I'm going to go ahead and type in, just as I have it here, negative 0.0032, whoops, got to turn it on, negative 0.0032 times 300 squared plus 300 plus 3. And that comes out to be, f of 300 is 15 feet. So, yes, that's bigger than 10 feet. It's going to go ahead, it's going to clear the fence, so yes, it will clear the fence. Unless that outfielder is a really good jumper, that's going to be a home run. Okay? And so we get to our assignment. So I want you to do those problems, and I've got the assignments attached on here. They're not very clear. It's not very good resolution. You can read them, but I went ahead and put the clear pictures in Google Classroom, and there's like 4 pages here. So I will see you next time.